our video lesson on our quad book for our page 5. So we open to page 5. You should watch a different video for page 4. But again, we're going to put our quadrilateral, our construction, around in the same section, the top half. This time we're going to use the short side, the 3-inch side, and we're going to intersect them at a perpendicular angle. So the easiest way to do this is do a vertical and a horizontal line. So in the top half of your page, I want you to trace the short side of your index card and its midpoint. So you're just going to make a little mark to show that that's the midpoint. And we're going to add the tick marks to prove it visually, basically. So we now have our short side and midpoint traced. Now we're going to trace another short side so that they intersect again, making a perpendicular angle, so 90 degrees. So you're just going to line up your midpoint with the midpoint that we have already traced. Let me make sure this is off a little bit. And we're going to trace so that it is at a 90 degree. Let's slide down a little bit. Okay, so we have two short sides intersecting at the midpoint, so they're being bisected, and they're at 90 degrees, so they're perpendicular. And then if you do not have a straight edge, like I said, you can use your index card. I'm going to use my protractor. Use a straight edge and protractor, and we're going to connect the endpoints. And hopefully you see the special quadrilateral we are constructing. Alright, so we have made, yes, it looks like another diamond, but it's different. It's smaller, and it is the special or the specialist quadrilaterals of them all, and that is a square. A square is also a parallelogram, and it's special and different from the rhombus that, yes, it has 4 congruent sides, but it's a parallelogram with 4 congruent sides and 4 right angles. Okay? 4 congruent sides and 4 right angles. So if you needed to verify the sides, we would do the same thing as we would do with the rhombus. So we're going to add now 2 tick marks because the sides are congruent and it has 4 right angles. So hopefully we saw on our video for a rectangle, once I put it in one, I'm showing it for all because consecutive sides, or consecutive angles, are supplementary. So if this is 90, then I would prove this would have to be 90, and so on. I know I kind of ran out of room here, but we're going to go ahead and label the vertices, the corners where the sides meet. I'm out of room, so I'm going to put my S here. Q, U, A, and R. Okay. So label your square, the vertices in your square, and the intersection of the diagonals. And so I'm going to go back to what we did with that rhombus, and I'm just going to trace the rectangle SRQ. And I'm hoping we see that when I rotate it, it's the same as QRU, which is the same as ARU and ARS. So if I know originally we had SRQ, then if I see that it overlaps on all of those, then I know that all these angles are going to be congruent. So this is a special side note and property of a square. We are going to show that all the angles get bisected by the diagonals. Well, if we know that this is 90 degrees and it gets bisected, so then it's always going to be 45, 45, 45, 45, and then our 90 at the midpoint where the diagonals meet. So, properties of a square. One, it has all the properties of a parallelogram. So instead of listing those out, I'm just going to say it in one statement. All the properties of a parallelogram. 2, it has also all the properties of a rectangle. Because it has 4 right angles, and that's what a rectangle is, a parallelogram with 4 right angles, it has all the properties of a rectangle. And because it has 4 congruent sides, it also has all the properties of a rhombus. Now, so this is why we kind of say a square is the special or the specialist of the quadrilateral, because it has all the properties of the parallelogram, of the rectangle, and of the rhombus. So, our little side note, and I hope you see it with the diagonals. Again, we have 4 right triangles. 2, 3, 4. Well, when the diagonals intersect, they bisect each other and they're perpendicular. The diagonals form 4 congruent special right triangles. They are forming 4 congruent right isosceles. Basically, you're always going to have a 45, 45, 90. 45, 45, 90 triangle. So now we're going to use those rules and those formulas for finding missing sides, finding missing diagonal measurements when we problem solve. So there is our square, which is on page 5. I'm going to go ahead and stop the video for our next special quadrilateral as you go to the video. Thank you.